Office hours. Today we're talking about integration by parts. So we're getting a new tool in our integration toolkit where we've really just kind of had like the power rule and U substitution. Now we're getting integration by parts, which is really just the analog of the product rule for derivatives, okay, just in the antiderivative world. Okay, so remember the formula tells you this. It says if you're trying to integrate something that looks like integral of u dv, then you get to choose what is u, what is dv. You have to differentiate u to get du, get the differential of it, I should say, and then you have to integrate, anti-differentiate to get actual v, and then you get the integral of u dv is equal to uv minus the integral of v du. Okay, so here's our setup. Okay, here's our example. Now, the first thing we kind of run into is we say, well, what would be a good choice for u or dv? Okay, well remember u you're going to differentiate, you're going to compute as differential. So if I set u equal to x squared, the derivative is 2x, it gets smaller in degree. Okay, so that's a good choice. So I'm going to say that u is equal to x squared, dv is equal to sine of x dx. Okay, now what's the differential of u? So du, that's the derivative, 2x dx. And then what is v? Well, v had to be, well, what function differentiates to, has differential sine x dx? That's minus cosine of x on the nose, okay? So as a first step, again, this is now u, okay? So this is u, and this whole thing is dv. So what does my formula tell me? It says that this integral should equal u times v, okay, uv, so that's minus x squared cosine of x, minus the integral of v du. Okay, well, what's that going to be? That's going to be minus 2x cos x. Like that. And I'll bring that negative out, and I'll rewrite this as minus x squared cos x plus, let's do, you could bring the 2 out as well. It doesn't really matter. I'll leave it alone, so I'll leave it inside. 2x cosine of x dx. Okay? So now this term, completely fine. This term, again, I'm like, well, look, if I chose u to be x squared, I got a 2x here that got smaller. So it stands to reason if I do integration by parts again, okay, so I do a different substitution. So let's call this, if you want to use u and v again, or u and dv again, that's fine. Maybe that's not the greatest choice. So maybe I should say something like u tilde, okay, is equal to 2x. And then dv tilde is equal to cos x dx. So this is cosine x dx. So then what would du be? That's just 2 dx. And then v tilde would be what? This is just sine x. Again, why am I using tildes in this case? Well, it's kind of imprecise to say in a previous step u and dv equals this, and then literally in the next step say u and dv equals something different. It's like that's bad practice. You want to use different variables for different steps. Okay? It's not the end of the world if you do it, but it's okay. It's better to use a different notation for it. So what do I get? Minus x squared cos x. Okay. So now look, plus the integral. What does the integral tell me? It's u dv. Remember, here's u, which I'm calling u tilde. Here's dv, so there's dv tilde. Okay? So I'm going to get plus what? uv, so this will be 2x sine x. Okay, so uv minus the integral of v du. So that's just 2 sine dx. Well, that's beautiful because I actually know how to anti-differentiate sine x. So what does this look like in total? Looks like minus x squared cos x plus 2x sine x minus 2 times the integral of sine x dx. Okay? Be very mindful with the negative signs. So then what do I get in total? I get minus x squared cosine of x plus 2x sine of x. Now what's an antiderivative for sine? So I'm looking for a function whose derivative is sine. That's going to be a cosine, but that's not right with that sign, so it needs to be negative cosine. Okay? So the negative cosine and the negative 2 will give me a plus 2 cosine of x. Okay? And then plus c, because this was an indefinite integral. All right? And then you could do kind of a sanity check and just say, okay, if I differentiated this, do I end up getting back to x squared sine of x? Ultimately, I will leave that step up to you. Okay, so there you have it. There's an integration by parts for something where our intuition was to choose the thing that differentiates to a smaller thing. So x squared goes to 2x, 2x goes to 2. Okay, I'll give another video where our intuition actually fails and the thing that we would naturally want to choose is actually not the right thing to choose. Okay, so hopefully this video was helpful in explaining integration by parts. Again, like, subscribe, comment down below, send me questions. These are my office hours after all. So send me questions, comment, all the stuff, and we'll keep it rolling.